Hello, you're welcome to my YouTube channel. Thank you for stopping by. Today we'll be learning about indices. Now, what's an index, by the way? An index is also known as the power or the exponent attached to a certain number, which is referred to as the base. So in this particular example I have here, we have a raised to power x. A is the base and x is the index. So if we have 3 raised to power 4, it actually means we should multiply 3 by itself 4 times. So 3 raised to power 4 will be 3 times 3 times 3 times 3. Now, there are certain rules that govern how you answer questions that are related to indices. When you have a multiplication sign between the two values that have the same base, then we can add up the powers. So a raised to power x multiplied by a raised to power y will give you a raised to power x plus y. While when there's a division sign and the bases are same, please note the bases have to be same for you to add or subtract the powers, as the case might be. Anything raised to power 0 is 1. If you have a scenario as we have in number 4 here that says a raised to power x, everything raised to power y, this implies that you need to multiply the powers. So you're going to have a raised to power x times y. Now, moving on to fractional indices. When you have a fractional index, what you need to do is that the denominator of the index becomes your root while the numerator becomes your power. So when you have a raised to power 1 over y, is actually just saying the white root of a. Now, look at number 6. If you have a power that is still a fraction, but your numerator isn't 1, it doesn't matter. The same rule applies. The numerator stays up and the denominator stays down. What do I mean by that? The denominator is the root while the numerator is the power. So a raised to power x over y will be the white root of a, everything raised to power x. And if you have a negative power, just know that it is the reciprocal of the original thing. So a raised to power minus x is same as 1 over a raised to power x. Now, if you're getting confused about any of these laws of indices, not to worry. We are going to be practicing them via exam style questions. Stay glued. Have you subscribed yet? Please do. Please like the video and share with your friends. Let's get right into it. In the first question here, we have been asked to simplify h raised to power 2 multiplied by h raised to power 5. Since the bases are same, we can then add up our powers. So this really means h raised to power 2 plus 5, which gives us h raised to power 7. Now, question number 2, we've been asked to simplify this particular expression. Please note the instruction here given is to simplify. You cannot solve this. There is no equal to sign. So don't go beyond simplifying. What do we mean by simplifying? Make it look neater and tidier. All right, now we have been asked to find the square root of 16x squared. Notice that the square root sign covers both. So that means we're really going to be looking for the square root of 16 multiplied by the square root of x squared. And that will be multiplied by 5y raised to power 0. Now, what's the square root of 16? That will be 4. What's the square root of x squared? That will be x. And what is 5 times y raised to power 0? Remember, anything raised to power 0 is 1. So this is just multiplied by 5. That means our answer here is 20x. We've been asked to simplify this. Now, when you have a situation like this where the bases have coefficients, in that we have 3 is the coefficient of x cubed here and 4 is the coefficient of x raised to power 4. What you need to do is multiply the numbers and then deal with the exponents too. So 3 times 4 will give you 12. And this is going to be x raised to power 3 times x raised to power 4 will be x raised to power 7. Remember, since it's a multiplication sign, we add up the powers. On to number 4. Now we have a division situation. When we see a division sign and the bases are same, we subtract the power. So we're going to have x raised to power 12 minus 3, and that will give us x raised to power 9. Now, we have a bracket around our y square being raised to power 5. Remember, this means that we will have y raised to power 2 times 5. And this is going to give us y raised to power 10. For question number 5, you need to pick the numbers, the coefficients first. So what's the coefficient in the first term here? It's 4 multiplied by the coefficient here is 1. So we're going to have, as far as numbers are concerned, we have just 4. P raised to power 5 times p raised to power 2 will be p raised to power 5 plus 2, and q raised to power 3 times q raised to power minus 4 will be q raised to power 3 plus minus 4, which is the same thing as 4. P raised to power 5 plus 2 will be p raised to power 7. Q raised to power 3 plus minus 4 will be q raised to power minus 1. So our final answer here will be 4, p raised to power 7, q raised to power minus 1. Now for question number 6, in this scenario, we've been asked to find the values of x in each situation. Please note, x has a different value depending on the question. So we're most likely going to have about 4 different values for x. So please pay attention to that. Now, for question number 6a, 2 raised power x equals to 128. When you have a scenario like this, you need to make sure that the number that serves as the base is same on the left hand side and on the right hand side. What do I mean? You need to write 128 as a base of 2. So what will 2 raised power what is going to give us 128? Let's write down our left hand side. 2 raised power x will be what? 2 raised power what is 128? What's raised power 7? Now that both sides are the same base, we can equate the powers, which means that in this particular question, x is equal to 7. Now, on to question B. The bases are same, but we need to just make sure we have one base on either side. So we kind of simplify our left-hand side. That's the more appropriate word to use. So this is going to be 2 raised to power x plus 9, because the multiplication sign is between both numbers, equal to 2 raised to power 13. Now that we can see this, we know that we can equate our powers. That means x plus 9 equals to 13, and that gives us our x as 13 minus 9, which is 4. So in this scenario, x is 4. On to the C question. Here we have 2 raised power 9 divided by 2 raised power x equals to 4. Remember, you need to write all the numbers to the same base. So this is in to base 2 already. So we can say this is 2 raised to power 9 minus x equal to, how do we write 4 as a base with a base of 2? That will be 2 raised to power 2. This means that 9 minus x equals to 2. And this means that 9 minus 2 equals to x. Again, our x turns out to be what? 7 here. So x is 7. Now, in this particular question, this is the first question we're encountering that has to do with a fractional index. You don't see a fraction. Yes, you have a fraction there. It's not just obvious. Now, on the left-hand side, we have 2 raised to power x, while on the right-hand side, we have 2 raised to power 1 over 3. Remember, when we had the base raised to power a fraction, the denominator was the root. Now, since our root is 3, it means that we have 2 raised to power 1 over 3. This implies that x here is what? 1 over 3. Question 7. Now, the mistake many students make here is that they just apply the power to one of the values in the bracket. I said one of the values. Yes, because there are two values in the bracket. In this bracket, we have 3 and p raised to power 2. So if we're going to open up this bracket, it's going to be 3 raised to power 5 and p raised to power 2, everything raised to power 5. So this implies 3 raised to power 5. What's 3 raised to power 5 going to be? 243. P raised to power 2, everything raised to power 5 will be p raised to power 10. Remember, we need to multiply the powers when we have this kind of scenario. Okay, for question 7b, we're going to divide. We do with the numbers first. All right, 18 divided by 2 is going to give us 9. And then we have x raised to power 2 minus 1, y raised to power 6 minus 2. And this is going to give us 9x y raised to power 4. Now here we have a scenario that we have a negative index. Remember, when you have a negative index, it's actually you could change it to a positive index, but you have to flip or find a reciprocal of your original value. This is what I mean. This actually means m over 5 raised to power 2. You flip it and then you make the power positive. And this implies m raised to power 2 divided by 5 raised to power 2. Our final answer here will be m squared over 25. Have you subscribed yet? Have you liked the video? Please pause and like the video and subscribe. Thank you. Now, question number 8. We have 81 raised to power 2 divided by 3 raised to power t equals to 9. What we need to do here is, like I said earlier, before you can solve this kind of question, you ensure that you have the same base and then you deal with the powers. Somebody else might say, oh, can't I just make t 3 raised to power t the subject of the formula? You could do that, but I think this is way easier to do. So 81 as a base of 3 is going to be, with a base of 3 will be 3 raised to power 4, everything raised to power 2, divided by 3 raised to power t equals to 3 raised to power 2. Now, this is going to be 3 raised to power 4 in bracket raised to power 2 will be what? 3 raised to power 8 divided by 3 raised to power t equals to 3 raised to power 2. Now, all the bases are same, so it's going to be 3 raised to power 8 minus t equals to 3 raised to power 2. Since the bases on either side of the equation are same, we can equate the powers. So 8 minus t will be equal to 2. Our t going on to the other side and 2 coming over here, we're going to have 8 minus 2 equals to t. 8 minus 2 is 6. So our t is 6. Now, question number 9 is a rather interesting question. All you need to do first is to find what y is, and then you will be able, y in terms of x, then you will know what your n is. Let me take that again. You find what your y is in terms of x, and then you can see what value n is going to be. So let's get right into it. Let's write this value. Let's write this as a fractional index. And also we'll write this as a fractional index. You do that, you have 1 mark already in this particular question. So this as a fractional index is going to be y. Remember, what stays down stays down. That is, the root is the denominator and the power is the numerator. Equal to, again, the base, our base is x on this side. The base, what is down stays down, and what is up stays up. Here we just have nothing, so that's 1 actually. So now that we've successfully written this, we can find what y is. to be able to find what y is, we need to make the power of y on this side, we need to make this 1. How do we make it 1? We multiply by its reciprocal. What do we mean by the reciprocal? The opposite, kind of the opposite of the number. So this is what we're going to have. If we multiply y raised to power 2 over 3, the reciprocal of 2 over 3 will be 3 over 2. Since we have done that to this side, then we have to do same to the other side. So this will be equal to x raised to power 1 over 6 times 3 over 2. Right? 2 here, 1, 2 here, 1, 3 here, 1, 3 here, 1. So this is going to be y on this side, while we're going to have 3 here, 1, 3 here, 2. And it will be x raised to power 1 over 4. Okay, so our y is equal to x raised to power 1 over 4. Now, remember, when we have a fractional index, it actually means that the denominator remains the root, which means I have 4 here, the base is under the root sign, and the numerator is the power. Our numerator here is 1, so we could write the 1 or do without. This implies that the n we're looking for is 4. So our n is 4. Now, for question number 10, we've been asked to simplify this. This is really similar to question number, where is it now? Question number 7. Remember, you apply the power to both what is inside the bracket, both the number and the variable. All right? So, to do this properly, we're going to have 5 raised to power 3 and x raised to power 4, everything raised to power 3. 5 raised to power 3 is 125, and x raised to power 4, everything raised to power 3, is going to be x raised to power 12. Remember, we need to multiply these two numbers. All right. Now, question B is similar, but now the power outside is a fraction. Don't be perplexed when you see a fraction outside the bracket. You do exactly the same thing. We apply that power to both the number and the variable. Okay, so this is going to mean 256 raised to power 3 over 8 and x raised to power 256, everything raised to power 3 over 8. Now, 256 raised to power 3 over 8 means, remember, the lower number, the denominator stays down. So we are looking for the 8th root of 256. And we are going to raise it to power 3. Okay? And this is going to be x raised to power 256 times 3 over 8. All right. I hope you understand. When you have a fractional index, what is up stays up. That means it stays a power. And what is down stays down. It stays a root. Okay. So what is the 8th root of 256? That is 2. Because you need to do 2 times 2 times 2 times 2, 8 times to get 256. So this is going to be 2 raised to power 3. And 8 here. 1, 8 here, 32. So this is x raised to power 32 times 3 is 96. 2 raised to power 3 is the same thing as 8. So our final answer is 8 x raised to power 96. So question number 11, easy peasy. The A part is just adding the powers because the bases are same. So we're going to have a raised to power 9. Here we open up the bracket, ensure that the power applies to every single element in the bracket. So it's going to be 5 raised to power 3, x raised to power 3, and y raised to power 2, everything raised to power 3. 5 raised to power 3 is 125, x raised to power 3, and this is going to be y raised to power 6. Remember, you don't add them, you multiply. 2 times 3 is 6. This is another fractional index question, but it's now a negative fraction we have here. So what you need to do is first and foremost make the power positive. How do you do that? You find the reciprocal of the value in the bracket. What's the reciprocal? It's just you flip it. So your numerator becomes 64 y raised to power 3, and your denominator becomes 27 x raised to power 12. Now we have a positive index, though still a fraction. Now, this implies, since the bracket covers both numerator and denominator, it implies that we are looking for a third root of both of them. This is saying we have 64 y raised to power 3 raised to power 1 over 3 and 27 x raised to power 12 raised to power 1 over 3. This implies 64 raised to power 1 over 3, y raised to power 3 raised to power 1 over 3 divided by 27 raised to power 1 over 3 x raised to power 12, everything raised to power 1 over 3. All right, so let's take them one after the other. 64 raised to power 1 over 3 is actually, say, what's the cube root of 64? That's going to be 4. 3 here, 1, 3 here, 1. So that is y. And for our denominator, what is the cube root of 27? That is 3. And here we need to multiply these two numbers. 3 here, 1, 3 here, 4. So this is x raised to power 4. So our final answer is 4y over 3x raised to power 4. Now, this is a similar question, but an easier one. Okay, so we have 16 p raised to power 16, everything raised to power 1 over 4. The trick here is do not get carried away with mixing up the 16 in front and the 16 that is the power. So this is 16 raised to power 1 over 4, p raised to power 16, everything raised to power 1 over 4. All right, so 16 raised to power 1 over 4 is saying you should find the fourth root of 16. And this will be 4 here, 1, 4 here, 4. So this is p raised to power 4. The fourth root of 16 is 2. So we have 2p raised to power 4. Now, this is also fractional power, but it's not negative now, so you don't need to flip it over. You just need to apply the fractional index to both the numerator and the denominator. All right, so what we're going to have in this question is 16 a raised to power 8 raised to power 3 over 4 divided by c raised to power 12, everything raised to power 3 over 4. All right, this is going to give us what? 16 raised to power 3 over 4 and a raised to power 8, everything raised to power 3 over 4. That's our numerator. Then our denominator will be c raised to power 12 times 3 over 4. So let's start out with our denominator. 4 here, 1, 4 here, 3. Okay, so for our numerator, now, so that means we need to find the value of 16 raised to power 3 over 4. Remember, what's down stays down. So we have 4 here, we have our 16, and what's up stays up. So that gives us 16 raised to power, the fourth root of 16 raised to power 3. All right. And then 8. Back here, we have 4 here, 1, 4 here, 2. So this is going to be a raised to power 2 times 3, that is 6, over c raised to power 3 times 3, that is 9. What's the fourth root of 16? That is, the fourth root of 16 will be 2. So the fourth root of 16 is 2. This is 2 raised to power 3, a raised to power 6, c raised to power 9. So 2 raised to power 3 is 8, a raised to power 6, divided by c raised to power 9. Now, this final question is the most interesting of them. It leads into an equation, and which will be rather interesting. Let's get into it. Now, we have 32 raised to power x times 2 raised to power x plus 3 equals to 1 over 4. Now, it looks complicated, but it isn't. Remember, when you have an equation that has index, you need to ensure that all the terms are in the same base so that it's easier for you to evaluate, or it's easier for you to simplify and then solve the equation. So let's start up with our 32. Okay, the only number we see that has a base here is base 2. So we should aim to make the other numbers. By other numbers, I mean our 32 and our 1 over 4 as a base of 2. All right, so 32 will be what? 2 raised to power 5. Everything raised to power x times 2 raised to power x plus 3 equal to, this is what? 1 over 2 raised to power 2. All right, we're almost there. Now let's open up this bracket. This is going to be 2 raised to power 5x times 2 raised to power x plus 3 equal to, notice that this has 1 over 2 raised to power 2. As a reciprocal, is going to be what? 2 raised to power minus 2. All right, we're almost there. Now let's tidy up our left hand side. Since the bases are same, we can add the powers because the multiplication sign is between them. So we're going to have 2 raised to power 5x plus x plus 3 equals to 2 raised to power minus 2. So this will be 2 raised to power 5x plus x will be 6x plus 3 equals to 2 raised to power minus 2. Now we have successfully had just one base on either side of the equation, and they happen to be same, so we can deal with just the powers. We can equate the powers. This implies we're going to have 6x plus 3 equals to minus 2. All right, now let's collect like terms. We have 6x equal to minus 2. This plus 3 goes over to the other side. It becomes minus 3. So we're going to have 6x equals to minus 5. And that will mean x will be equal to minus 5 over 6, because we're going to divide both sides by 6. So this is our final answer here. Thank you for sticking around. I hope you learned a thing or two. Please remember your laws of indices. They are crucially important. And don't be perplexed when you see questions like this. All you need to do is to ensure that you make all the numbers have the same base. Then you simplify either side of your equation and collect like terms, and then voila, you have it done. Thank you for watching. Thank you for liking the video. See you in the next one. Bye.